In this lesson, we're going to talk about how to multiply polynomials. So by now you know how to add and subtract polynomials, so now we're going to talk about how to multiply. So when multiplying expressions with variables, what we do is we multiply the coefficients and we add the exponents. So in this example, we have 4x squared times negative 2x cubed. So the coefficients are the numbers in front of the variables, and the exponents are the numbers, the small numbers above the variable. Okay, so we can basically rewrite this expression as 4 times x squared expanded is x times x. And then we have negative 2, and then we have x cubed, which expands to x times x times x. So then to simplify this, we have our coefficients here, the 4 and the negative 2, and that makes negative 8. And then we have 5 x's being multiplied, so that would be x to the 5th. So this step right here is really kind of just unnecessary. It's really just to kind of demonstrate why you can add the exponent. So we multiply 4 times negative 2, and that gives us our negative 8. And then we have x squared times x cubed, which we know we can expand to x times x times x times x times x. Or we can just look at our exponents. 2 plus 3 is 5. And we can just do it that way. So there's really no need to expand this. Again, this is just to kind of demonstrate this property. Okay, one thing I should point out is that when we add our exponents, it must be the same variable. So for instance, if we have y squared times x to the 3rd, we wouldn't be able to add those exponents because they're different variables. So they must be the same variable, like they must be all x's. Okay, second thing here, use distributive property when multiplying a monomial, which is a one-term polynomial, times any other polynomial. So we're going to look at an example here. So we have 4x times, parentheses, 3x squared plus 2x minus 3. Okay, so all we're going to do is we are just going to use the distributive property where we take the term out in front and just distribute that to every single term inside the parentheses. Okay, so first thing I'm going to do is I'm going to highlight my coefficients because we know that we're going to multiply those. Okay, notice I am highlighting the sign with the number, and then I'm also going to highlight my exponents. So when a variable doesn't have an exponent, that exponent is 1. So for instance, these variables right here are x to the 1st power, and there is no variable for this last term. Okay, I'm going to highlight my exponents. So we have 1, 2, and 1. So now we're just going to multiply. So when multiplying, we multiply the coefficients. So 4 times 3 is 12. And then we have x to the 1st power times x squared, and we add the exponent, so that would be x cubed. Okay, the next term we have 4 times 2, which is going to be positive 8. And then we have x to the 1st power and x to the 1st power, so that would be x squared. Okay, the last term we have 4x to the 1st times negative 3. So first of all, 4 times negative 3 is negative 12. And then we just have an x to the 1st power, so that's just going to be 12x to the 1st power. Okay, it's really not necessary to write this x to the 1st power. You can just write x, but I like to write that just so people don't get confused. Okay, so again, these numbers out in front we got from multiplying our coefficients, and then these exponents we got from adding our exponents, because that is the rule when multiplying variables. All right, let's look at another example. So looking at this example, if we look inside the parentheses, you should notice that we can actually simplify this a little bit. Okay, so we're going to simplify first. And we can combine the 3x and the negative 5x. Okay, when I rewrite my parentheses, I am going to write it in standard form. where we start with the highest degree exponent. So this term is going to go first, so 2x to the fourth. Okay, then I can combine my 3x and my negative 5x. That makes negative 2x, so these come second. And lastly, we have our constant term, which would go last. I'm going to move this parentheses over. Okay, then we have our term out in front. Okay, so now I'm going to go ahead and distribute. So I'm going to distribute my monomial to all the terms on the inside. I'm going to multiply my coefficients, and I'm going to add my exponents. Okay, so this one doesn't have an exponent, but I am going to put a 1 there, just so we remember to add that. Okay, so my first term is going to be negative 2 times 2 is negative 4. And then x cubed times x to the fourth, 3 plus 4 is 7, so negative 4x to the 7th. And then my next term is negative 2 times negative 2, which is positive 4. And then I have x cubed times x to the first, so 3 plus 1 is 4, so this is x to the fourth. And then my last term, I have negative 2 times positive 9, which is negative 18. And this term doesn't have a variable, so it's just going to be x cubed. And there's my answer. Okay, so now let's look at if we're distributing more than just a monomial. So here's an example where it is a binomial times a binomial. So in this case, we're not just distributing one thing, we're actually going to be distributing two terms to the second parentheses. So I'm going to be distributing the x to the parentheses, and then I'm going to be distributing the 5 to the parentheses. Okay, so I'm going to do this in different colors. So first thing I'm going to do is x times x, which is x squared. Then I'm going to do x times negative 4, which is negative 4x. And then I'm going to do 5 times x, which is positive 5x. And then I'm going to do 5 times negative 4, which is negative 20. Okay, once you're here, then you can combine like terms. So in this case, I have my two middle terms, negative 4x and 5x are like terms since they're both x terms, so I'm going to combine that. So your final answer should be x squared, and negative 4x plus 5x, it's just going to be 1x, or x, and then minus 20. So this method of distributing is fine when it's a binomial times a binomial, but when we get into more complicated examples, when you're doing something, say a trinomial times a trinomial, it can get confusing with all the different terms. Okay, so one method that I like to use to multiply is just called the box method, and it's very similar to like a multiplication chart. Okay, so box method is when you first draw a box that kind of corresponds to these. So this is going to be a 2 by 2 box, since there's two terms here and two terms here. So I'm going to draw a box that just looks like this. Okay, and it's a 2 by 2 box, meaning 2 across and 2 down. Okay, then what we're going to do is we're going to take these numbers, the 5x minus 4, and put it on the outside. And I'm going to split the terms, and then I'm going to put these terms on this side. So 8x and positive 7. Okay, then from here, it basically just acts as a graphic organizer for your terms. Okay, so first thing I'm going to do is I'm going to do 5x times 8x, which will go in this box in the top left-hand corner. So that's 5 times 8 is 40. And then we have x squared, since x times x is x squared. Okay, next term I'm going to do is I'm going to do 5x times 7. So 5x times 7 is going to go in this box right here. So 5x times 7 is going to be 35x. And then I'm going to do negative 4 times 8. So negative 4 times 8 is negative 32x. And the last thing I'm going to do is this one right here. So negative 4 times 7. So negative 4 times 7 is going to be negative 28. So what's nice about the box method is it's easy to see which terms you can combine. So if we can see here, a lot of times it does happen to be the terms across the diagonal. So these two are like terms since they're both x terms. So my final answer, combining like terms, is going to be 40x squared. Then we have 35x and negative 32x. That is positive 3x. And my last term is negative 28. Okay, so when you're doing this, you don't even need to draw these arrows. You can actually just look at the box. So the whole point of me drawing the arrows is just to show you that what I do when I'm doing the box method here is the exact same thing that we're doing here. The only thing is these terms get put in the box. So like I said, with a 2 by 2, I don't think it's necessary to do the box method, but I really like to use the box method to multiply. All right, so let's look at another example. Number 3. So here's what you don't want to do. Okay, so don't write this down. You cannot distribute an exponent. That is not allowed. That's not something you do with exponents. So what you need to do is you first have to expand first. Okay, so what I mean by that is when we have something squared, that's really x times x. So when we have this parentheses squared, that really means we're taking 2x minus 3 and multiplying it by itself, 2x minus 3. Okay, because then it just becomes a similar problem to the previous one, and I'm actually going to go ahead and use the box method for this one as well. Since it's a 2 by 2, a binomial times a binomial, I'm going to draw a 2 by 2 box. If you prefer to just use distributive property, then by all means feel free. Then I'm going to write the terms on the outside. Okay, then we can multiply. Okay, so 2x times 2x, that's 4x squared. And then we have 2x times negative 3, that's negative 6x. Okay, 2x times negative 3, that's negative 6x. And then we have negative 3 times negative 3, that's going to be positive 9. Okay, just like the previous one, we have our like terms here across the diagonal. So we're just going to add those together when simplifying. So we have our final answer is going to be 4x squared. Negative 6x and negative 6x is negative 12x. And then we have plus 9. Okay, number 4. So number 4, we're actually multiplying 3 polynomials. We're multiplying 3 times 2x minus 1 times 4x plus 2. So first thing we're going to do is we're going to distribute the constant first. Okay, we're basically going to multiply the first 2 polynomials first. So 3 times 2x is going to be 6x. And 3 times negative 1 is negative 3. So we don't distribute the 3 to the second parentheses because the 3 is only being multiplied by the second thing. So we only distribute to the first parentheses. The second parentheses stays the same. Okay, now we can go ahead and multiply. So I'm going to just use distributive property for this one just to kind of mix it up. Okay, so we have 6x times 4x. So 6 times 4 is 24, and x times x is x squared. Okay, next term we have 6x times 2, so 6 times 2 is 12x. And we have negative 3 times 4x, which is negative 12x. And then last one we have negative 3 times positive 2, which is negative 6. Okay, then we combine our like terms, so we have these middle terms here, a positive 12x and negative 12x that can be combined. So our final answer is going to be 24x squared. And these terms actually just cancel each other out because we have positive 12 and negative 12 make 0. So they cancel each other out, and then we have minus 6. Okay, so we can use multiplication and addition to solve some word problems. So number 5 says the dimensions of a rectangular garden are 3x plus 10 and 2x minus 6. What is the perimeter of the garden? So here's my rectangular garden. Okay, we have the length and the width. So it doesn't matter where you put it. So this is 3x plus 10, and this is 2x minus 6. So to find the perimeter, what we do is we add up all the sides of the rectangle. Well, if we have a rectangle, then we know that the opposite sides are the same length. So this is going to be 2x minus 6, and the bottom part is going to be 3x plus 10. So if we're finding the perimeter, we're just going to be adding all of these together. Okay, so instead of actually writing out 3x plus 10 plus 2x minus 6 plus 3x plus 10 plus 2x minus 6, if we know we're adding, we can just classify our like terms. So we know we're going to be adding together all of my x terms, and then we're also going to be adding together all of my constant terms. Okay, so first adding together all my x terms, I have 2x and 2x, that's 4x, and then I have 3x and 3x, that's 6x, so for a total of 10x. And then I'm going to add together my constant terms. I have 10 and 10 makes 20, and negative 6 and negative 6 make negative 12, so 20 plus negative 12 is going to be positive 8. So there's my perimeter. It is a word problem, so we should say the perimeter of the garden is 10x plus 8. Okay, since there's no units, we're not going to worry about that. All right, the next one says, what is the area of the garden? So remember, to find the area of a rectangle, we just do length times width. So we're actually just going to multiply these two polynomials here. So we're going to do 3x plus 10 times 2x minus 6. Okay, for this one, I'm going to go ahead and just use the box just to kind of do both ways. If you prefer distributive property, then do distributive property. So this is going to be 3x plus 10 and 2x minus 6. It doesn't matter which one you put where. You can switch these. It doesn't matter. Okay. So then multiplying here, 2x times 3x, so 2 times 3 is 6, and then we have x squared. So you should be noticing something. When we multiply a linear binomial times a linear binomial, in the top left-hand corner, that's always going to be an x squared term. Okay, in this corner is always going to be a constant term, and these are where your x terms go. Okay, that will become important later. Okay, then we do 2x times 10, so 2 times 10 is 20, so this is 20x. And then we have 3x and negative 6, so 3 times negative 6 is negative 18x. And then we have 10 and negative 6, so 10 times negative 6 is negative 60. All right, then we can combine like terms. So remember when we do the box method, like terms are usually across the diagonal. Not always, but a lot of times they are. So our final answer is going to be 6x squared. 20x and negative 18x is positive 2x. And then we have minus 60. So the area of the garden is 6x squared plus 2x minus 60. Okay. This last example, it says, suppose there was a rectangle-shaped hole in the middle of the garden with these dimensions. Okay, so this is a 2x minus 4 by 5x plus 8 size hole. Find the area of the shaded region. So we know the area of the entire thing. We need to find the area of the smaller one, and then we're just going to subtract them. Okay, first we're going to find the area of the hole. We find that by multiplying, so it's going to be 2x minus 4 times 5x plus 8. Okay, and I'm going to go ahead and just use distributive property for this one. So 2x times 5x, that's 10x squared. 2x times 8 is 16x. Negative 4 times 5x is negative 20x. And then negative 4 times positive 8 is negative 32. Then we're going to combine like terms, so 16x and negative 20x can be combined because they're both x terms. So it's going to be 10x squared. 16 and negative 20 is negative 4x. And then minus 32. So there's the area of the hole. And we have the area of the garden, which is up here. So now we're just going to subtract. So subtract to find area of the shaded region. Okay, so my first polynomial is the one from up here. It's going to be 6x plus 2x minus 60. And we're going to be subtracting the polynomial from here, basically the area of the whole. So this is 10x squared minus 4x minus 32. And you do need to keep it in parentheses because we're not just subtracting the 10x, we're subtracting this entire thing. All right, so this first polynomial represents the area of the garden. The second polynomial represents the area of the whole. And we're going to subtract to just find the area of the shaded region. So remember, when we are subtracting, what we do is we distribute the negative to each of these terms, which basically just flips the sign. So the first polynomial stays the same. Sorry, this should be 6x squared. 6x squared plus 2x minus 60. And then we flip the signs of everything here. So positive 10x squared becomes negative 10x squared. Negative 4x becomes positive 4x. And negative 32 becomes positive 32. Then from here, we just combine like terms. Okay, so we have our x terms, our x squared terms, which we can combine. We have our 2x terms, our x terms, which we can combine. And then we have our constants, which we can combine. All right, so my final answer, 6x squared and negative 10x squared is negative 4x squared. 2x and 4x is positive 6x. And then negative 60 and positive 32 is negative 28. So the area of the shaded region is negative 4x squared plus 6x minus 28. Okay, now I'm going to go over a couple of the practice problems. So number one, we're just multiplying a monomial times a polynomial. So remember, we're going to multiply the coefficients. And then we're going to go ahead and add our exponents. So anything that has no exponent is really to the first power. Okay, so distributing, we have 3 times 4 is 12, and b squared times b squared, 2 plus 2 is 4, so b to the 4th. 3 times 5 is 15, so plus 15, and b squared times b to the 1st, 2 plus 1 is 3, so b to the 3rd. 3 times negative 1 is negative 3, and then there's no variable here, so it's just going to be b squared. Okay, number 5, we're multiplying 3 things. Remember, with these ones, first thing we do is we distribute to the first parentheses. So 4 times 5 is 20a. 4 times negative 6 is negative 24. The second parentheses stays the same since we're only distributing to the first. And then we can multiply any way we want. So I'll do this one using the box. Okay, so here's 20a, negative 24, and then 6a and positive 3. Okay, first thing we're going to do is 6a times 20a. So 6 times 20 is going to be 120a squared, since a times a is a squared. Then we're going to do 6a times negative 4. So 6 times negative 24 is negative 144a. And then we're going to do 20a times positive 3. So 20 times 3 is 60. and then we have an a. And last thing we're going to do is negative 24 times positive 3, which is negative 72. Okay, then we can combine like terms. So in this case, it's going to be the negative 144a and the 60a. So simplifying, we have 120a squared. Negative 144 plus 60 is negative 84a, and then minus 72. Okay, next one we're going to do is number 9. So this one, first thing, remember, we need to do is expand it. So we need to write it as 2 plus 3n times 2 plus 3n. And then we distribute. So I'm going to use distributive property on this one. 2 times 2 is 4. 2 times 3n is positive 6n. 3n times 2 is positive 6n. 3n times 3n, so 3 times 3 is 9. And then we have n squared. Okay, combining like terms, our two middle terms we can add together. So writing in standard form, we start with the highest degree exponent, which is going to be the 9n squared. Then our middle term, 6 plus 6 is 12, so plus 12n. And then we have plus 4 at the end. Okay, last one I'm going to go over is number 11. So it says the dimensions of a window are 4x minus 7 and 3x minus 2. Okay, so here's my window. And I'm going to put my dimensions on there. So this is 4x minus 7 and then 3x plus 2. It says there is a hole cut out of the glass that has dimensions 2x plus 1 and x minus 2. So maybe something that looks a little bit like this. With those dimensions, this is 2x plus 1 and x minus 2. We want to find the total area of the glass. So the part that we're looking for is this part right here. Okay, so this is similar to the one that we did in the notes. So first thing we need to do is we need to find the area of the window. And we're going to do that by multiplying 4x minus 7 times 3x plus 2. So 4x times 3x is 12x squared. 4x times 2 is plus 8x. Negative 7 times 3 is negative 21x. And negative 7 times 2 is negative 14. All right, combining like terms, we have 12x squared. 8x and negative 21 is negative 13x minus 14. So there's the area of the window. And then we need to find the area of the hole, which is going to be these two multiplied together. So 2x plus 1 times x minus 2. Okay, using distributive property here, 2x times x is 2x squared. 2x times negative 2 is negative 4x. 1 times x is 1x. And 1 times negative 2 is negative 2. All right, again, combining like terms, these terms in the middle. So we have 2x squared, negative 4x, and positive 1x is negative 3x minus 2. Okay, so now to find the total area of the glass, we're just going to subtract these two things. Okay, we're going to do the area of the window minus the area of the hole. So it's going to be 12x squared minus 13x minus 14 minus 2x squared minus 3x minus 2. Distribute the negative here. So we have 12x squared minus 13x minus 14. And then 2x squared becomes negative 2x squared. Negative 3x becomes positive 3x, and negative 2 becomes positive 2. Then we can combine like terms. So I have my x squared terms, I have my x terms, and I have my constant terms. All right, so our final answer, so 12x squared and negative 2x squared is 10x squared. Negative 13x and positive 3x is negative 10x. And negative 14 and positive 2 is negative 12. So that should be your answer.